Increasing and decreasing function. Differentiation. Unit 7, example 4. Find a range of values of x for which y equals 2x to the power 4 plus 4 over 3 x cubed minus 2x squared plus 14 is decreasing. When we're looking at decreasing and increasing function, we'll be looking at the gradients. If I quickly sketch the gradient, call this the y dx. So I'm plotting the y dx against x. The y dx is greater than 0 here, so that's a positive slope. The y dx is less than 0 here, so that's a negative slope. So that's positive, so greater than 0, this is negative. Along the x-axis here, the y dx is 0. So this is a positive value, negative value, and here is 0. Where the y dx is 0, that's stationary. So that is stationary. So we've got this function here, and whenever we're doing the y dx, or whenever we're finding the y dx, we have to make sure y is in the form of x to the power n. Then we can find the y dx will be equal to n x to the power n minus 1. So that's the process that we apply in finding the gradient. The function we have is y equals 2x to the power 4. X to the power 4 is the same as plus 4 over 3 x cubed, again it looks like that, minus 2x squared, again that looks like that, plus 14. The 14 doesn't look like that. Every term, because there are 4 terms here, 1, 2, 3, 4, they all have the same variable, and the variable here is also x, but to power 0. Anything to power 0 equals 1. So 1 times 14 is 14. Now that function looks like that. Now we can differentiate. The y dx equals 4 times 2, 8, x, 4 minus 1, 3. That's 4 minus 1. Plus 4 over 3 times 3, x to the power 2. That's 3 minus 1. Minus 2 times 2, so that's 4, x to the power 2 minus 1, power 1. Plus 0 times 14 is 0, so that's gone. Then we get 8x cubed plus 3 cancel 3, so that'll be 4x to the power 2 minus 4x. So that's the y dx. But we're looking for decreasing function, so we're looking for that. For a decreasing function, the y dx has to be less than 0. So we can then say, for a decreasing function, the y dx has to be less than 0. Therefore, 8x cubed plus 4x squared minus 4x is less than 0. We can divide both sides by 4. We get 2x cubed plus x squared minus x is less than 0, because I've divided both sides by 4. X is a common factor here, so I can take x out, so I get 2x squared plus x minus 1 is less than 0. Now I need to factorize that in the bracket here. That reminds me of a quadratic expression, which is ax squared plus bx plus c, where a equals 1, b equals a equals 2, b equals 1, and c equals minus 1. So in this case, I need to find ac when you're factorizing. So ac is 2 times minus 1, that's minus 2. I need two numbers that I can multiply the product. I get -2. And when I add them together, the sum, I get 1. So 2 and -1, that should equal to 1 when you add them together. So all I need to do is put x here and put x here. So that means 2 times x is 2x. -1 times x is -x. 2x minus x is x. So what I'm going to do is I'm going to replace the x here with 2x minus x. We get x, the common factor, 2x squared plus 2x minus x, that still gave x. So that's the same as that. -1 is less than 0. Now I can see a common factor here, 2x and -1. So 2x is common here, so I get x in there. That's the x for that one. And the x is a square bracket. And the x here will be 2x, the common factor, then get x plus 1. And here, because there's a minus, I write -1. If I'm taking minus out, the sign next to it will change. So I get x plus 1. Close the square bracket, less than 0. Now I can see a common factor again. X plus 1, x plus 1. And then I'm left with 2x minus 1. I get x, open square bracket, 2x minus 1, that's a factor, and x plus 1 is another factor, all less than 0. If I set them to 0, set that to 0, set that to 0, set that to 0, that will be x equal to 0 for that one. 2x minus 1 equal to 0. 2x equals 1. X equals a half. And this one, x plus 1 equal to 0. X equals -1. Now I've got the roots. These are the roots here now, where it crosses the x-axis. So if I sketch the graph, and we know x equals to 0 here, so these are the points, and x equals -1, and x equals a half. Because we're sketching the cubic curve, because that's cubic. So we're sketching that. Because it's cubic, it's going to go through these 3 points. And because it's positive cubic, it will start from the third quadrant. The third part, this is first, second, third. So it goes through that, comes here, and then it goes there. Remember that the axis here is the y, the x. The positive part of this is along this side, that's positive, and that's positive. The negative part here, this is negative, and that's negative. So we're looking for the negative because decreasing is negative. That's decreasing, and this is increasing. So these are the decreasing factor here. So this point here is a half, and that's 0, and this is -1. So that's decreasing. So that's the decreasing factor, and these are the increasing, and that too is increasing. That means the y dx is greater than 0, and here the y dx is less than 0. So it's a negative slope, and here it's a positive slope. Now I need to write down the range of x values, and they are, the range we're looking for is x is less than -1. So we say x colon x is less than -1, open curly bracket and close curly bracket, union plus that one here, open curly bracket, x colon, because we're talking about x-axis, and then we start with 0, the smallest, and the highest is a half. So that will be 0 less than x less than 1/2, close curly bracket. And that's the value or the range or the domain of x that satisfy the function as decreasing function here and there. So just to remind you, it's x colon. It means we're talking about x-axis. X is less than -1 along here. close curly bracket, union. We're now going for that range here, the domain here, open curly bracket, x. We're talking about x now, that's what I meant. And the range now, or the domain, which is 0, is less than x, is less than a half. So from there to there. So union means plus that plus that.